good. What an introduction, though. Thank you very much. Incredibly happy to be here, to be honest. So warm welcome also for me. One of my favorite conferences takes place again, so I'm really, really happy to be back. It's my third time here, but it's definitely the hottest time here. So I was walking outside, I was like melting. I don't know how you guys do this, but it's just way too much for me. Okay, I'm happy I made it, to be honest, because I was at a customer the recent day, and what I did was we had an application, and when I was, here's a side note, when I was preparing this this talk, I made this story up, but now it's not made up because this bug literally came in when I was in the preparation for this talk. So what we did was we had like an application where you could like do some store things. Of course, I broke it down, but basically that describes the bug pretty well. We had a store where we had an overview. Of course, we can also go to the shopping cart here. And you can also go back, and from that overview, you can lay some things into the shopping cart, right? As you know it, I mean, that's how you just do your online shopping. And when you go to the cart, you can see what you got in there, and you have the total price calculated, okay? And the current stand was that we had the bug that this number up here, this 3 in this case, was not updating. That was a bug. Okay, so we had that, and we were working on this, or tried to work on this. And well, we were standing around on that table. One developer was sitting there, and the other team members were standing behind him, trying to give him some inputs, and we were trying to fix the bug. So how did we do this? First of all, we had this products component in our case, where we had like 2 services. One is the product service, and out of the product service, we were calling like the load products just to show all the books you have seen in the overview, right? So we did a subscribe, and we tried to save the books there. And when you click on that particular card, we used another service to add something to the card. And then we subscribed to it, and we showed a toaster, which you have just seen on the corner in the right-hand side. Okay, so that was the first thing. The next thing was our checkout service, and the checkout service was the only thing which had like connection to all the other bits and pieces. So what we did on that particular checkout service was we created a subject inside of that service. We were exposing this as an observable to be read-only, so nobody else can emit something into that subject, right? Because we were smart in this case. And every time we're adding something to the card, we nexted our products into that particular subject, so we spread the word in our complete application. Okay, this is how we solved the bug. Our shell component then, this is basically the eager-loaded thing you saw on top, right there, which was holding like the number of items. Okay, it was receiving all the things, well, initially, so it had a card products count, it's only interested in the count, and then it was getting the card products initially, because when you start the app, you want to know from the back end, hey, how many items do I have in my shopping cart? However, what it also had to do is subscribe to that event, which was thrown by the service, saying, hey, if something happens, I want to be notified, I want to be updated. In our checkout component then, which is the other lazy loaded part, we had 2 signals. One was the card products, one was the total amount, which we have seen, which gets calculated for you. And we had a fancy pants RxJS operator, which is called merge. And basically, this is the same code we have seen in the previous component. It's also getting interested in the card products, and it also wants to be notified when the card products change. And we subscribe to this, and then we set the card products, we calculate the total amount, we set the total amount, and we were done. Okay, so that was basically it. So we were standing there in front of that table, and we were implementing this, and everybody had like a bad gut feeling on this. Okay, that's not good. We were kind of like in a situation where we felt something is wrong here. It doesn't feel right. There's a lot of code noise. So there's a lot of things going on which shouldn't go on to like fix that simple bug where a number is not updating. Right? There was a lot of code we had to do, right? It was very likely that with all these subscriptions we have done, with all the code and all the code noise we have done, our UI and our data got out of sync. That means that if we send our shopping cart, or if we send the book we just laid into the shopping cart to the backend, and everything was technically correct, we didn't reflect that particular number in the upper right corner. Although, from the data perspective, from the communication perspective, everything was correct, but it wasn't reflected in the UI. So our UI and our data easily gets out of sync. Okay, basically, what every subscribe is doing, it's creating an own copy of that data and holds that, no matter where you do that. So you subscribe, you're taking something out of that stream, and you hold that. And then that instance, whether it's a service, a component, whatever, is in charge of also updating it, managing that whole thing. That's a responsibility. The state we had in this case was not only in one place, it was spread across the whole application. We had state in services, we had it in components, we had it everywhere. And there was way too much. And this was not what we wanted, basically. So we thought about this, and we said, okay, the state is living in way too many places here. It's very cumbersome, it's very difficult to get each one of those places up to date, and then tell him the latest things. So we thought about this. We thought, how can we make this better? And we were like, wouldn't it be good, wouldn't it be nice if we would have like a products component which now has state, better be not holding the state itself? Wouldn't it be nicer if the shell or the header component, if you will, which now holds state, would better not holding the state? Wouldn't it be nicer if the checkout component, which now holds state, not holding the state? Okay? And wouldn't it be nicer to have it in one place where we have, for example, a service where we lay down the state? Wouldn't that be better? So we were in charge, like, who owns the data? We were taking a step back and saying, okay, who owns the data in our case? Who's like the one sitting on the data and managing it? And what we did was we took the same box, the same things, everything the same, but we put the state, like the vision of the state, we had the view of the state a little bit more upper in the hierarchy. Okay, so we pulled a little bit more. We didn't want to go for that particular number. We wanted to go step back, who owns that complete data? Okay. And then our boss came in. And he said, while we were like sitting there and discussing and blah, 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 our boss came in and said, hey, we got to do something. And we were like, hey, what you got? He was like, we got to do WebSockets now. And we were like, what? And he was, we have to do WebSockets. So if you have one instance of the app open and another instance of the open, and you have like the same account, and if you lay something into the shopping cart, it should also be reflected into your application. So all of a sudden, our state was not only triggered by our application, it was also modified from the outside, so something else was pushing state into our application. Okay? So we just reached that a little bit like later on. We just wanted to focus on that problem. But what we did was we took the same thing and just put like a view of state on this. What did we do? We had a shell component which should only read the state. Then we had this lazy loaded things, the lazy loaded parts, which were like product and checkout, which can read the state and trigger some state changes, not manipulating the state directly, but trigger some state changes. And we wanted to have one single source of truth, which was the checkout service, which was holding the state. So that was our thing in mind. So we went this step back, okay, to take a look at the data model, which is lying behind it. So we did that. Okay, so how did this turn out? Our checkout service now got stateful. Okay, so we had this cart products here as a signal, and we computed all the derived states from it into computed signals. Derive state everywhere you can, because it gets automatically recomputed, and then you can work with it. So that was our checkout service now. And then our shell component went from this to this. Our checkout component went from all that code, all that fancy RxJS operator which we got, where beginners still stumble a little bit on, to this. Isn't that nicer? Isn't that easier to follow? Isn't that remarkable how our code got more beautiful when we thought about state in the beginning? We just changed the way we think about state. We didn't change anything at all. We did no library. We did no fancy pants upgrade of everything. We just laid the state to a specific place and thought about it in the beginning. That's all we have done. And our code improved significantly. And this is how I welcome you to my talk, why state is the most important part of your Angular application. Before we go further, I would like to introduce myself. Hi, I'm Fabian. I'm a Google developer expert for Angular, Microsoft MVP, and very active in the community. So yeah, I love this, being part of the community and also those community conferences. So again, thanks. State like the most important part of your Angular application. But the question is, where do we see state in our Angular application? Okay, it's like omnipresent. And what you have to accept is that you have to deal with state in your Angular applications. You have to. It's the truth. Don't hate me. I'm just saying it. Don't kill the messenger. You have to deal with state in your Angular applications, if you want to or not. Where do we see state in our Angular applications? Well, first of all, the DOM. The DOM is state. The DOM is nothing else than the rendered state of your application. Okay, and the last bits, the last meters, so what you set in your signals, what you set in your properties, and the synchronization from that data model to the DOM, to the UI, this is what Angular does for you. Whether you use the async pipe, whether you use like Zone.js signals, whatever. So the synchronization of that data model to that what you see in the particular UI, that reactivity, Angular is doing that for you. So you don't get in touch with this so many times, but if you think about it, you're doing it all the time. So the DOM is state. It's the state of your application. Basically, the UI is nothing else than a function where you pass in the state, and the result of this is your UI. That's what it is. We also have component state. So every component you have deals with state. Either it's getting the state passed, which would be a good thing, or it holds the state by itself. But all those components which are rendered inside of your application build like the state of your application. We have stateful components, we have stateless components, but they can all hold state. If we have like a component which should stateless be on the one side, it can also have state. That doesn't make sense though. When it's stateless, why can't it have state? Okay? Think about a form. You have a form component which is only taking care about like a user login password form or something like that. And it getting passed, or we're doing the form there, like the form group, and when the user changes this form object, it changes the state of that particular form, and therefore the state of that particular component. Nobody cares about this unless you say login, and then you spread the word. But when the user clicks cancel, you don't have to tell anybody. So closed component state, presentational components, can also have state, but they're dealing with it on their own. Mostly they're getting it passed from their mother components, where we have the state, and we're passing it down from container components, so to say. Okay, so we have container components, which have like multiple child components, and we're holding the state, like your to-do list, and we're passing the things down. Okay, that's a pattern which is really, really, really powerful, And basically, it's the first step, the first door you do into state management. Every component keeps track of this on their own. This would absolutely be possible. But think about doing the groceries with 10 of your friends, and everybody has a list, a grocery list. And you go into the grocery store with 10 lists, and everybody has to talk to everybody to tell the other what he has got already in the cart and what not. That's a nightmare, isn't it? Wouldn't it be nicer if you would hold one grocery list and tell the people what to get? This would be way easier. That's exactly the relation between container and presentation and components in this case. You are the container component, you're holding the state, and then you're just telling the others what they basically should do. But we also have state which is valid for a complete feature. Imagine you have a profile, you have a dashboard, you have like a settings page. There's a state which is only valid for this particular feature. No other feature needs that. But this feature needs it. And many components are reaching out to this and want to have a part of that state. So there's feature state as well, every time. But we also have something bigger, which is application state. Application state, for example, whether the user is logged in or not. This is totally independent from every feature we do. The user is logged in or not. We have a log level, it's like debug or error or whatever you have. It's totally independent from every feature. This is application state. Centralize the state when you need it, but localize it when possible. Lay it as close to the things where it has to be, okay? But the way, like, make it as big as it has to be then. That's like a rule of thumb. But your route is also state. We have the DOM state, now we have the route state. Where's the route state? The route is nothing else than the serialized state of your application. When I get my route and I pass it to somebody else, he should basically see the same things that I do. Think about the route as the serialized state of your application. In fact, when I was doing the presentation, I'm always doing those color themes and trying to get my fonts and colors matching to the charts, and I'm having a screenshot later. But here I have an example of how such a route can look like. We have the users, we have the page 1, count 30, sort ascending. So basically that state reflected in the UI. So you all have been using a state management system all the time without knowing it, probably. That's interesting, isn't it? Just the way we think about state. Here I'm trying to match my colors and the font colors and everything in my presentation. You can see like the color codes are persisted in the URL. That's state. That's just state which is getting synchronized. So the URL is nothing else than the persisted state of your application. State also can impact your architecture. So what does that mean? Well, maybe this is just a fake architecture, right? But we know a lot about that things if we think about state. Okay, so here we have like an authentication state. We know it has to be shared because it's not connected to any feature. But if you have a feature which has its own state, you know that this file has to live under checkout, under products, or inside of your feature. Always think about it. You're telling a story to the next developer where you lay down your files. There's a reason behind it. So you know a lot about your file folder structure already when you only think of your state and your complete application. Also, the routing impacts state. So what that means is we can also turn that around and say the state impacts routing. They are connected with each other. So most probably you can do the product checkout and share it on the right-hand side. If you're using NgRx Classic, for example, you can take this more or less as an example, but otherwise it's just a mental model behind it. But if we have a route, a lazy loaded feature called product, we might have a state connected to that particular product feature. And also, if we have a lazy loaded thing checkout, we might have a state part, whether it's provided in root signal store, whether it's NgRx Classic, doesn't matter. We have a part which is only valid when this checkout pops up. Okay, we can't go from a product to a checkout state because these things are lazy loaded. We don't know if the user has been there before. So everything we need in both of those things, we have to give it in shared. This is not a one-to-one relationship. Don't get me wrong on this, but it gives you hints, it gives you insights on how you can structure your application. And this is a good starting point where you can start thinking about things. And then you can shape it, then you can bring it to your applications, place it inside of your code. But the starting point is a very, very neat one. State also impacts components. We have seen that in the code example. So the components, what should they do? They should only listen to state changes. They should only listen to state changes. So they should have something, and when something on that particular thing changes, they should listen and reflect it. But the components are also, that's what's the closest to the user. So what do they do as well? They also trigger state changes. That's the button you click, that's inside of a component. That's the blur effect you do, that's inside of an input, which is inside of a component. So components are really, really powerful. And what I always use as a rule of thumb is get the logic out of your components. Components are the main building block in our Angular applications, isn't it? Without them, nothing would work. I always see that we try to put everything we can in that TypeScript file because we can inject, because we can subscribe, because we can use the fancy pants RxJS operators, can we? Let's do it. And they grow, and they grow, and they grow, and they grow. Makes them hard to test. Makes it hard to grasp what's going on. Every bit and piece of your code which you do not need to render the template should not be inside of a component. Components are like the main building blocks of Angular applications, so keep them as a treasure. Treat them like gold. They should be easy to follow. And get the things elsewhere where you can better test them. Make them as lightweight as possible, all your components. But the best thing about state, which I encountered, is that it provided guidance. I want to be completely honest with you. I had many projects concerning Angular. Some of them were pretty successful. Some of them were absolutely not successful at all. Looking back, what did all these successful projects have in common? It was the way we thought about state. And the way we thought about state gave us guidance, gave us a pattern inside of that team. So what we did was, we could implement features and bug fixes always the same. We had no discussions in successful projects where to place that particular service, where to place that particular part, where to do that component, because they do it always the same. And all of a sudden, we were a team of like 4 members, so me and 3 others. And if I would have implemented a feature with one person, was the same code as if the other 2 persons would just program that thing together. Because we all had the same mindset, because state was providing us a guidance how we should do things. It got almost boring writing Angular applications, which is a good thing. This is how it should be. I remember one project where my team was asking me, hey, can we increase the coverage on SonarQube to 95% because it was so easy to reach? And I went to the management and was like, hey, can we do that? And our backend here today? Backend developers? No backend? Okay, then I can tell, oh, a few, but don't mind. So the backend was like, hey, please don't increase the coverage. We haven't that coverage at all. We were like, well, we are ready. You can do. That was pretty nice. All because of guidance, all because of that state things. That state is kind of like that particular layer we have in between, that layer of abstraction right in the middle. Right? On the one side, we have other components listening to it. On the other side, we have all those services which now, if we have that stateful layer in the middle, can concentrate on what they should do. Because in the solution we had before, we were kind of like mixing things. We had a stateful service, and it was doing a lot more. However, now service A can do only the HTTP communication. Service B can only show you the notifications. Service C can only do the logging. It doesn't take care who's calling it. It doesn't take care of anything else. It just does its things, because state is in the middle. And the components can reach out to it, can read it, and it gets modified by the services or like any HTTP calls. Of course, this also applies to when you have components and you have state which is only valid for that particular component. It should live with the component, like a one-to-one relationship. This is what I meant with localize and centralize. Okay, you have a component, can have state, and when you get rid of the component, you don't need the state anymore, then you can put it in a one-to-one relationship. Signal Store does that pretty good. We have a talk on that later, I think, in the agenda. I would really recommend this one. But the feature state can live, because it has shared, which gets spread over different components inside of that particular feature. And all of a sudden, WebSockets, implementing something with WebSockets becomes easy. Why? Because the WebSockets only modify the state. There's like one particular place where you can react to those WebSockets, things that are getting pushed in your application, and the components only listen to that changes. There you go, now you implemented it, it's good. Because you have that layer of abstraction. And this is how our service looked like as we implemented the whole thing. So our checkout service, guess what, only was doing the HTTP communication. No fancy pants things inside of this. Clean, easy to test coverage. There you go. That was a state layer. I don't want to get too much in detail about this, but that was our state layer. So we had a state which was only taking care about the products. Then we had the with computed, and this is a Signal Store example, but you choose your own. Okay, you choose your fighter. I'm always with the NgRx, but you choose your fighter if you want to. So we had a computed, which are just derived values. And the advantage of this is that they are getting recalculated every time the source gets recalculated. So easy to do. See those things as like stateful services. Then we had all the methods, how we can manipulate the state inside of that particular Signal Store. And when that thing is being injected for the first time, we just call a method, we just call load all, and we have something on the state. So that was our state layer. It's pretty neat, right? It's not a big layer, but it is a layer. And then our checkout component went to this. It doesn't get cleaner than that. It can't. Then we had our shell component, which was looking like this. We were also only doing the checkout store, and it has no idea if WebSockets manipulate the state or if any HTTP communication is manipulating the state. It doesn't care. It just reflects what is in the state, and this is how components should work. They take what's on the state and reflect that. Here we have a products component. Here we have a store which is provided now on the component level, and also we have the products by categories now, so we can only do some manipulation, some shaping for the data if we want to brush it up before we like display it. But again, this is not inside of the component. This is on the state level, which makes it easier to test and all that kind of things. If you want to test a component, it's always asynchronous, because the rendering of the template is something asynchronous. So if you just want to test a component with its created things, you have this fixture detect changes. If you want to test it, it's always asynchronous. We always ask us the question, what is the data model now? Who owns the data model? And how does the data model change? And we were still standing around that table and looking for that bug and wanted to like fix it. And we found out that the real bug was the way we thought about state, or we didn't think about state. That was the bug. And not that particular number which was not updating. That was only a symptom. The real source was how we thought about state, or we didn't think about state. Don't let state happen by accident. This is what we have seen in our first solution. We had like subscribes everywhere, everybody creating their own copy, and then you had to manage all the different copies inside of your application to bring them up to the latest level if something happens in your system. Don't let state happen by accident. We have the greatest UX designers and CSS wizards out there to make applications, making them look really nice and really pretty and all that kind of things. And what we often forget is like creating the state for applications. This should be us developers making that step back, seeing, okay, what's the state? How do we manage the state to reflect all those beautiful things our UX designers and so on and so forth have created? So let's create state. Let's design state. Let's own state. Because in the end, state is the most important part of your Angular app, isn't it? Thank you very much.